Welcome to solverfy.
In this problem on the topic of oscillators, we are told that a car bumper which has a spring constant of 430 kilonewtons per meter compresses when a car of mass 1,300 kilograms collides with a wall at speed 2 meters per second. We want to find the maximum compression of the bumper in this collision. Now, if we apply the conservation of mechanical energy to the car, we'll call condition 1 to be before the collision and condition 2 to be after the collision. If we assume that all of the kinetic energy of the car is converted to potential energy and stored in the bumper, we know that x1 is equal to 0 and v2 is equal to 0. And so the conservation of energy tells us that all the initial energy must equal to all the final energy. E1 is equal to E2. That's a half m v1 squared, the initial kinetic energy of the car, plus the initial elastic potential energy stored in the bumper, a half k x1 squared, must equal the final kinetic energy of the car, a half mv2 squared, plus the final elastic potential energy stored in the bumper, a half kx2 squared. So simply, the initial kinetic energy of the car, half mv1 squared, must be all converted to elastic potential energy in the bumper, which is a half kx2 squared, which means we can find the maximum compression of the bumper, x2, by rearranging this equation. And x2 is equal to the square root of m over k, where k is the spring constant of the bumper, and all this multiplied by v1. So this becomes the square root, the mass of the car, 1,300 kilograms, divided by the spring constant, given to be 430, times 10 to the power 3 newtons per meter. All of this multiplied by the speed at which the car collides with the wall, 2 meters per second. This gives us the maximum compression of the bumper to be 0.11 meters.